Let's see another algorithm, decimation in frequency FFT algorithm. It is also known as radix 2 DIF FFT algorithm. Let x of n is an n-point sequence where n is a power of 2. So what we have to do in DIF algorithm, the output sequence x of k is divided into smaller and smaller subsequences. In this algorithm, input sequence x of n is partitioned into two sequences, each of length n by 2 samples. So consider these partitions are like x1 of n and x2 of n. So we can write x of n equal to x1 of n plus x2 of n. The first sequence x1 of n consists of first n by 2 elements of x of n, and second sequence x2 of n consists of last n by 2 samples of x of n. That is x of n equal to x1 of n plus x2 of n, where x1 of n equal to x of n, where n ranging from 0 to n by 2 minus 1, and x2 of n equal to x of n plus n by 2, where n ranging from 0 to n by 2 minus 1. Say this equation 1 and 2. Now n-point DFT of x of n by 2 factor is given as x of k is equal to n0 to n minus 1 x of n omega n of nk, where k ranging from 0 to n minus 1. Separating x of n into two sequences x1 of n and x2 of n, we will get x of k equal to summation n0 to n by 2 minus 1 x of n omega n of nk plus summation n ranging from n by 2 to n minus 1 x of n omega n of nk. By replacing values, so first summation x1 of n into omega n of nk, second n0 to n minus by n by 2 minus 1 x2 of n omega n of n plus n by 2 k. So simplifying, what we will get, x of k equal to summation n0 to n by 2 minus 1 x1 of n omega n of nk plus omega n of nk by 2 summation n0 to n by 2 minus 1 x2 of n omega n of nk. So simplifying, we will get, now we have two options when value of k is even and when value of k is odd. So when k is even, e raised to minus j 2 pi k value will be 1. So x of 2k, which represent value of k even, is equal to summation n0 to n by 2 minus 1 x1 of n plus x2 of n omega n of 2 nk, which is equal to x of 2k equal to summation in bracket x1 of n plus x2 of n bracket complete multiplied by omega n by 2 nk, where this bracket is replaced or represented as f of n. So x of 2k equal to summation n0 to n by 2 minus 1 f of n omega n by 2 nk. Similarly, we will solve when k is odd. So for value of k odd, e raised to minus j pi k equal to minus 1. Therefore, x of 2k plus 1, which represent value of k odd value, x of 2k plus 1 equal to summation n0 to n by 2 minus 1 x1 of n minus x2 of n omega n of 2k plus 1 into n. Simplifying, we will get in bracket x1 of n minus x2 of n omega n of n omega n by 2 nk. So which is equal to x of 2k equal to summation n0 to n by 2 minus 1 g of n omega n by 2 nk, where g of n equal to x1 of n minus x2 of n bracket multiplied by omega n of n. So this is nothing but decimation in frequency FFT algorithm, or we can say DIF FFT algorithm.